learning to see. There are different kinds of drawings. Some are loose, some are stylized. But in order to make accurate drawings that mimic reality, we have to be able to master certain strategies that will allow us to copy what we see accurately. Our objective for this module is to lay the foundation to accurately translate what we see to what we draw. Why is this important? Because if you want to become a draftsman or artist working in comics, animation, or even painting, you have to have a solid foundation in the basics. With a solid foundation, you can innovate and find your own style later. Creating forms. Let's talk about shapes and forms. When we talk about shapes, we talk about flat, two-dimensional enclosed areas like squares, circles, or triangles. When we talk about form, we refer to three-dimensional objects that have height, width, and thickness, like cubes, spheres, and cylinders. All drawings, and even all of nature, have these disguised shapes and forms underneath everything. And this is where we're going to start learning about drawing. All drawing stems from one or more of these forms. Learning how to draw well begins with finding simple shapes and disguised forms in everything. If you can draw these forms convincingly, you can potentially draw anything. A sphere can be a cup or human head. A cube can be a house. A cylinder can become a goblet or human leg. A cone can be a dress. Pyramids can be roofs or towers. In terms of shapes, we often start with a square. With its equal sides, we can construct a variety of different shapes. And because its sides are all equal, we can use it as a basic means of measurement, simply because it is a known quantity. But first, let's learn how to divide a square. We do that by creating two intersecting diagonals. Their intersection marks the midpoint of the square. From there, we can separate the square, or even a rectangle, into 4 equal parts. From the square, we can even draw a circle, because we know that the radius of the circle, or the distance between its center to any point in its circumference, is the same. And of course, we can even draw a triangle. What's more, by placing the square in perspective, we can create other three-dimensional forms. Here's a quick demo. So here we have a square, and it's a simple matter of finding the midpoint by drawing intersecting diagonals and giving us the ability to separate the square into 4 equal parts. From the square, we can create a circle. If we place the square in perspective, we can also create a circle in perspective. And if we create a three-dimensional block out of that initial square and circle, we can create a cylinder. And not just a cylinder. If we take the same process as before, drawing the square, finding the midpoint, and then drawing the circle, we can also create a cone. Okay, let's look at this fancy looking teapot. What shapes and forms do you see? How about this still life photograph? Can you simplify these objects into their basic forms? We'll break these photos down further in a later demonstration. Now let's talk about eye level and the concept of perspective. We'll discuss the particulars of linear perspective such as 1 to 3 point perspective in a later module. But for now, I'd like to introduce these concepts as part of the foundation of any drawing. Perspective is a tool to create illusions of depth. It is a concept that states that parallel lines converge at a point on the horizon called the vanishing point. This vanishing point is an imaginary concept, but it helps us create the illusion of depth in our drawings. Eye level, on the other hand, is the foundation of perspective. Eye level is also called the horizon line. Eye level refers to the height at which your eyes observe an object. To put it simply, the eye level is the level of where your eyes are at. So imagine you are drawing a table and you are standing next to it. If you were to draw the table, it would probably look something like this, because the table is below the level of your eyes. But if you were to sit on the floor and draw the table, it would look something like this. You'd be able to see the underside of the table, because a large portion of the table is now above the level of your eyes. This is a simple concept, but a lot of beginners ignore the principle of eye level in their drawings. This is also a powerful concept, because in your drawings, you can actually control the eye level. Every drawing that aspires to look convincingly three-dimensional has to have an eye level or horizon line. Now, each drawing can be above, below, or at the horizon line. To further demonstrate this concept, this is a block positioned at eye level. The lines of its various sides converge at two separate vanishing points. This block, on the other hand, sits above the eye level, and because of this, you can see the underside of the block. All converging lines go down to their respective vanishing points. Lastly, this block sits below the eye level. You can see the top of the block, and the parallel lines of its sides go up and converge their respective vanishing points. Now, sometimes the vanishing points can be within the picture plane, which makes the perspective more pronounced. But sometimes the vanishing points are outside the picture plane, which allows for a more natural-looking point of view. In the same way that one's perspective on blocks changes depending on the eye level, cylinders are also governed by the same principles. When drawing the cylinder, remember that at eye level, its ellipse appears to be a straight line. As the ellipse rises above the eye level, its edge nearest you curves up in an arc. As the ellipse descends below the eye level, the arc is reversed, and the edge nearest you curves down. In summary, before you begin a drawing, ask yourself this question: where should I place the eye level in my drawing? Or maybe there are different parts of my subject which are above, below, or at eye level. So plan accordingly. Okay, let's start with some basics. How do we make accurate drawings given a reference or even a model from real life? Well, we're going to look at 3 strategies that will help you out. First, find the midpoint. Second, use plumb and level. And third, take comparative measurements. To demonstrate, the best tool to use for these strategies is your own pencil. Take your pencil in one hand and hold it out like this with your elbow locked. Now, with one eye closed, sight the subject looking along the pencil. Now use your thumb to take measurements along the length of the pencil. Let's look at this simple setup. Here I'm taking comparative measurements of the subject matter using my pencil as a measuring tool and my thumb to mark the measurements. This vertical position of the pencil is what we refer to when we talk about plumb, while this horizontal position is what we call level. Let's apply the 3 strategies I mentioned earlier. First, I'm determining the midpoint of the entire composition, which is somewhere here. Next, using the level position, I'm taking comparative measurements of the parts of the setup. Using the top of the bottle stopper as a standard unit of measurement, I observed that the entire length of the bottle is approximately 3 times that of the width of the stopper. While the length of the block is 2 times that of the stopper. I'm also observing that the width of the stopper is as long as the length of the block. Also, using my pencil, I can determine the imaginary lines and angles that will allow me to draw the composition better. Now you might be asking, what made you decide to use the stopper as the unit of measurement? Well, trial and error and finding the measurement that seems simplest and applicable to the various parts. We will see all of this applied in a demonstration in a later video.